Evaporation, condensation, and humidity. You've all seen a puddle of water dry out. The temperature is below the boiling point. So what happened to the liquid water? Discuss. Evaporation is vaporization that takes place slowly at the surface of a liquid. There will always be some particles with enough energy to escape the liquid, even at temperatures far below the boiling point. They enter the gas phase, forming a vapor above the liquid. So the liquid water becomes a gas, and the puddle dries up. Here you can see particles with high enough energy can escape from the surface of the liquid. These form a vapor above the liquid surface. But we saw earlier that water vapor can also condense from gas into liquid. It turns out that evaporation and condensation are taking place all the time. They form an equilibrium. Particles are always escaping the liquid, and particles in the vapor are always getting recaptured by the liquid. Nothing seems to happen if the rates of evaporation and condensation are equal. This is called an equilibrium. A lot is happening on the surface of this glass of water at the microscopic level, but there's no change that you can see. If there's air movement, like a breeze, or the air is very dry, the particles move away before they can get recaptured. The vapor separates from the liquid, and the liquid evaporates away like in this lake, or as you see happen with puddles on a dry or sunny day. That's also why fans make us cooler. The moving air carries away the liquid evaporating from our skin so it can't come back. That carries away the high-energy water particles, leaving us cooler. But if there's a lot of water vapor in the air, if it's humid, this doesn't work. As fast as some liquid particles evaporate into the air, other particles come back to replace them. We don't cool off. That's why it can be uncomfortable if it's both hot and humid. At a given temperature, there's an equilibrium between liquid particles becoming gas and gas particles becoming liquid. At higher temperatures, the equilibrium allows for a lot more gas particles, since the particles have more average energy. Relative humidity is the percentage of vapor in the air compared to the maximum possible at that temperature. Air will feel dry if the amount of vapor is much less than what is possible. Air will feel humid if there is as much vapor as possible, so no more vapor can leave your skin. Evaporation is important to hurricane formation and weather patterns. The evaporation cools the ocean, but transfers energy and heat into the atmosphere. This is also why global warming could result in more storms, as warmer water increases this energy transfer.